All right, we're going to take a look. Welcome back to your favorite fundamentals college math class. We're going to take a look at OR probabilities. So previously we looked at the probability of A and B occurring, both events occurring. In this section, we're going to look at the probability of either event occurring. Like example 1 is a good example. If you're pulling one card from a deck of cards, what's the probability of selecting a king or a queen? So a king or a queen is a winner. You're just pulling one card, right? We're going to go through that. Well, you've got two types of OR probabilities. You have mutually exclusive events and you have non-mutually exclusive events. So what are mutually exclusive events? A and B are mutually exclusive if it's impossible for them to occur simultaneously. Okay? If it's impossible for them to occur simultaneously. So it's always safe to use the non-mutually exclusive events, because if it's mutually exclusive, this part will just be, you'll just be subtracting 0 right there anyways. So I always like to use, I just assume that they're non-mutually exclusive so that I can run, so I won't mess it up either way, okay, because it's safe to use the non-mutually exclusive formula. So let's look at this one, for example. All right, if one card is randomly selected, what's the probability of selecting a king or a queen? Okay, well, first of all, is this mutually exclusive? In other words, is it impossible for them to occur simultaneously? In other words, can you pull a card out that is a king and a queen card? Is there a card that's both a king and a queen? And hopefully you say no, right? So this is, oops, it's not letting me write here. This is mutually exclusive. So being mutually exclusive, the probability of A or B occurring is probability of A plus probability of B. Now, I did say it is safe to use the not mutually exclusive formula all the time, which is probability of A or B is probability of A plus probability of B minus probability of A and B occurring. So let's go ahead and do it that way. What's the probability of pulling out a king or a queen? It'd be probability of pulling out a king plus probability of pulling out a queen minus the probability of a king and a queen. So let's do this. What's the probability of pulling out a king? How many kings do we have? There's 4 kings in the deck out of 52. What's the probability of pulling a queen out? 4 cards, 4 out of 52. And how many cards are a king and a queen? Well, it's not possible to pull out a king and a queen card, right? There's no card that's both. That's why we said it's actually mutually exclusive, right? This is actually mutually exclusive because the ending part is just 0. So it's an 8 out of 52 probability. In other words, both of those go into 4, 2 out of 13, or 0.153846. There's a probability if I draw a card that I draw a king or a queen. Now this is pretty basic, like you probably could have got to that just by visualizing it, right? How many winners are there? There's 8 winners out of 52. You're just pulling one card out, right? This is a mutually exclusive event, so it's actually pretty straightforward being mutually exclusive. Now this one says, if you're picking a card again, what's the probability of selecting a red or a king? first of all, is this mutually exclusive? Are there any cards that are red and kings? Yeah, so this is not mutually exclusive. This is not mutually exclusive. Again, we're always going to use, just to be safe, we'll always use the not mutually exclusive formula anyways. But let's run through this. Probability of pulling out a red or a king would be probability of pulling a red plus probability of pulling a king minus probability of a red and a king. All right, so how many red cards are there? See the whole first row and the whole third row there? Yeah, so we got 26 out of 52. How many kings are there? I got 4 out of 52. So let's go ahead and circle those first of all. So here's all my reds. There's all 26. Now let me circle my kings. Here's all my kings. Can you see how there's a couple that were double counted there? So I have too many winners. Why do I have too many winners? Well, this is not mutually exclusive. I got to subtract out the double count. So how many are red and king? That one right there is red and king, and that one, right? There's 2 cards out of the 52 that I've double counted. There's 2 red, what's the probability of pulling a card that's a red and it's a king? 2 out of 52. So that's why we subtract that with the not mutually exclusive, is we don't want to double count our winners. So we have 26 plus 4, I got 30 minus 2, I got 28 out of 52. Let's see, both those going to 4, 7 out of 13, or 0.538461538.5, so about 53.8%. That's the probability of pulling out a card that's a red or a king. Not mutually exclusive, right? All right, next, so suppose we flip a coin and roll a die. What's the probability of getting a head and a 6? So is this mutually exclusive? Well, can we have a head and a 6 at the same time? Yeah, so this is not mutually exclusive, right? Well, let's see. So again, if you're revisiting this, you're flipping a coin and you're rolling a die, same time, like one in one hand, one in the other hand, or whatever, right? A winner is a head or a 6. Either one's a winner for us. We just want one of them to occur. Does that make sense? So it's the probability of flipping a heads plus we're adding in the probability of rolling a 6, but we have the double count that we got to subtract out. So probability of flipping a heads is 1 out of 2. Probability of rolling a 6 we know is 1 out of 6. Minus, now let's go to the side for a minute. What's the probability? This is from last time. Probability of a head and a 6. Well, that'd be the probability of rolling a head times the probability of rolling a 6. So 1 out of 2 times 1 out of 6. So it's a 1 in 12 probability of a heads and a 6, right? So we got 6 out of 12, we got 2 out of 12, I get a common denominator minus 1 out of 12. So I got 7 out of 12 is the probability of I get a head or a 6. head or a 6. In fact, let's make this visual for a minute. If I wrote out the sample space here, I could get a heads and a 1, heads 2, heads 3, heads and a 4, heads 5, heads 6. I could do a tails with a 1. Now, the winner is, we're wanting to flip a coin and we want a heads or a 6. Either one's a winner, a heads or a 6. Let's circle all the heads. All of those are winners, right? Now let's circle any 6s. Anytime we got a 6. 2 of them are winners. Did you see that the one in green and red is double counted? Right? That's why I'm subtracting that out. I've double counted it. I really only have 7 total winners out of 12 possibilities to try and make that visual for you, right? So thus the not mutually exclusive formula, right? So again, it's always safe to assume it's not mutually exclusive and use the not mutually exclusive formula. Let's do a roll two dice this time. We want the probability that the sum is odd or the sum is 4, right? Now this is mutually exclusive. You can't have a sum that's odd and a sum that's 4. That's impossible. So this is mutually exclusive. But again, we're gonna assume that it's not. I know it's mutually exclusive, but we're gonna assume it's not, because it's always safe to use that formula. All right, so we got the probability that the sum is odd or sum is 4. We're just that either of those is a winner, right? So what's the probability that we roll 2 dice and get a sum that's odd, plus probability that the sums up to 4, minus probability the odd sum is odd, and sum is 4. Let me come down here. Probability sum is odd or sum is 4. All right. Well, what's the probability that the sum is odd? Let's start circling those. 2 plus 1, 3, 1 plus 2, 3. There's some that are odd. Those add up to 5, 5, 5. Looks like I got 18. There's 36 possible rolls. There's the probability that the sum is odd on the 2 die that we roll, right? Now, how many of these have a sum of 4? Those ones in blue. It looks like we have 3 out of 36. How many of these are sum odd and they sum up to 4? There's no crossover. That's why this is mutually exclusive. There's none that are the same. I didn't double count anybody, right? So there's 21 out of 36, or 7 out of 12, or 0.583 repeated. That's the probability that the sum is odd or that they sum up to 4 when I roll 2 dice. Again, rolling 2 dice. This time we have the probability of the sum. Bless you. So we want one of the die to show number 1. We want the sum to be odd or one of the die to show a 1. Is it mutually exclusive or not? Well, the question is, could I roll it and have the sum be odd and one of them showing a 1? That could happen, right? I could have a sum that's odd with one of the numbers being a 1. So this is not mutually exclusive. All right, so probability of A or B, probability of A is probability of B minus probability of A and B. So we got probability that the sum is odd plus probability that one number is a number 1 minus probability that the sum is odd and one of them is a number 1. All right, so how many of these are odd? That was the 18 of them. 18 odd possibilities out of 36. So 18 out of 36. Plus, how many of them have a number 1 in it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of them out of 36 have a number 1 in them. Now, how many of those, what's the probability of pulling one that they sum up to odd and one of the numbers is a 1? In other words, how many crossovers did we have? How many both of those? Yeah, I think, let's see, 1, 2, 3, 4. Good, yeah, 5, 6. Yep, 6 out of 36. So I've double counted 6 out of 36. So I got 29 minus 6, 23 out of 36. Or 638. We've got this table. It's got people that have received a speeding ticket or not a speeding ticket, and if they had a red car or not a red car, right? Let's do part A. Now, part A is from last section. It's asking us, what's the probability if I was to go in and grab out of this bag of people that I grab somebody with a red car and they have a speeding ticket? Probably a red car and a speeding ticket. Well, how many have a red car and a speeding ticket? Looks like there's 15 of those out of the total 665 people. Both those go into 5, so 3 out of 133. Let's do part B. What's the probability that you pull out somebody that has a red car or they have a speeding ticket? Doesn't matter. Either one's a winner. So that'd be probability that you pull out somebody with a red car plus probability you pull out somebody with a speeding ticket minus any possible double count, meaning I have a red car and a speeding ticket. All right, so let me erase this black one here. How many have a red car? Total people, total winners with a red car. 150 out of 665, right? That's how many people have a red car. Plus, what if we were to reach into the bag and pull out somebody with a speeding ticket? How many speeding ticket winners do we have? 60 winning speeders, right? Out of how many people? Now we're going to pull out, was there any double counted? Is there anybody with a speeding ticket and a red car? Can I pull out of the bag anybody with both? Yes, I have double counted 15 of them. 15 out of 665 have both a speeding ticket and a red car. That's the probability of pulling out a speeder and a red car. All right, so this is not mutually exclusive, of course. So this ends up being 150 plus 60. What's that? 210 minus 15. I got 195 out of 665. Both those go into 5, and that'll give you 39 over 133. Or 0.29323. 0827 if you want to punch that in. And that's your OR probabilities. Thanks so much for watching. Take notes. See you next time.